Hi, my name is Alex Davis. I'm an associate professor in the Department of Engineering and Public Policy at Carnegie Mellon. My background is in psychology and human decision-making, and today I'm going to talk to you about communicating uncertainty to aid decision-making. So I'm going to talk about four things today: public decision-making, the science of risk perception, the science of risk communication, and I'll give some examples. So this view on public decision-making and decision science that I'm going to talk about today is well documented in the literature. These are some seminal papers that are done by a colleague here at Carnegie Mellon, Baruch Fischoff. So please take a look at these if you're interested in reading more. So the perspective is that good individual decision-making requires a couple of things. It requires understanding and knowing how the world works, and to do that we need the best science, and requires knowing what world we want. So the science tells us the relationship between our actions and future states of the world and some uncertainties with that. Knowing what world we want is our values and the things that we care about. So good public decision-making requires good individuals' decision-making. So individuals need to have some sense, hopefully a relatively accurate sense about how the world works, as well as what they want, and requires an understanding of the perspectives of others. And this is because different people who maybe agree on the science have different values and they care about different things. And so they have to understand the perspectives of others such that they can come to some sort of compromise that results in good public decision-making. And so decision science, focusing on risk perception, risk communication here, aids the scientific part of this. So aids in helping understand how people helping people understand the world. So risk perception and risk communication are tools of decision science to help individuals understand how the world works. This promotes good individual decision-making and good public decision-making by helping them understand the science. So I'll talk about the science of risk perception. So risk perception research is a science of how people think about the world, in particular, how people think about risk. And in particular, we want to know what are the risks, costs, and benefits that people care about. There are some things that people are very focused on, and there are some things that individuals may not care about at all. Risk perception research is particularly interested in what's the perceived magnitude of each of these things. There's a lot of work on costs and benefits, particularly understanding people's subjective valuation of benefits. But here we'll focus on people's perception of risk. So I'll talk about a classic paper on subjective perception of the risk or the judged frequency of different lethal events. This is a paradigm creating paper in the 70s, and the paradigm has followed similarly. And in the paradigm, individuals are asked to assess the frequency of different events, and then that's compared to the actual relative frequency or frequency of those events. So for example, in one of the sub-studies in this paper, participants are asked to estimate the frequency of deaths per year from 40 different sources, and the perceived frequencies are then plotted against the actual frequencies. So the true frequencies are on the horizontal axis on a log scale, and then we have the perceived frequencies, the geometric average of them across all participants, again on the log scale. And if participants are perfectly accurate in this study, then what we get is we get observations on the diagonal here, meaning that the mean response equals the true frequency. And what you can see is that there is deviation, and there's a systematic pattern where low frequency events are overestimated in their subjective frequency, and high frequency events are underestimated. Okay, so for example, botulism is perceived to have a high frequency relative to its true frequency of death. Again, we have this underestimation of low frequency events and overestimation of low frequency events and underestimation of high frequency events. Another effect that was observed in this study is that if you anchor people by saying, well, just as a reference point, motor vehicle accidents are about 50,000 per year versus, well, electrocution accidents are 1,000 a year, and participants are given one or the other of these. What you find is that the intersection point of the subjective curve, this curved line with the diagonal line shifts. And essentially what's happening is that the low frequency events move up toward the anchor. So depending on the anchor, instead of individuals having a fixed subjective scale in their mind that has the frequency of events in there, if a different anchor is given, the frequency of events tends to shift toward that toward that anchor, and the low frequency events are affected more, and they're pulled up toward the anchor, and they're assessed to have a higher frequency than when a low anchor is given, and then those low frequency events tend to be shifted downward. So there's a number of studies in this area that get at all sorts of different effects, like the first one that we showed with the compression, the second one showing some anchoring. And so in general, individuals have some consistency across response modes. If you ask them to rank things, if you ask them to rate things or judge ratios of frequencies, they'll give you some consistent numbers, but they're not going to be accurate exactly. And they're going to show some systematic biases. So this risk perception research has found consistently that individuals need some direct information, direct communication to help them understand risk and to help them understand the probabilities. And here's just a list of some of the classic studies in the area. As an example, we tried to do both, which was in a recent paper, we tried to assess the potential errors that decision makers make, as well as try to provide them a communication partially about some cumulative risks. This was cumulative risks from a flood. And so this study asked participants to imagine that they've just moved to a city, they buy a $300 house, a 30-year mortgage. There's going to be a 1% probability of the house being destroyed by a flood each year. And so what is the percent chance that their house would be destroyed in a 30-year period by a flood? Okay, so it's a 1% annual probability, and they own it for 30 years. So the true probability is, or percent chance, is 26. The most frequent response in the study, and this is a well-replicated result from prior work, is to use the mean heuristic, which is to give a 1% response, which is that the probability over 30 years is just the probability in any particular year. An alternative response is the additive heuristic, which actually gets you pretty close, which is just to sum up the 1% chance over each of the 30 years. Now, we augmented this by giving participants 1 point on the curve by telling them the truth for 1% chance, and then we asked them, well, what would a 4% chance each year result in, or a 2% chance each year result in? And it turns out that overall, it led them to use the additive heuristic more, but it didn't necessarily lead them to understand exactly the relationship between the cumulative probabilities and the annual probability. So one of our conclusions from this paper was that you really need to provide those cumulative probabilities directly for the relevant endpoints and not hope that people can infer them or interpolate them from other points on the curve. So this leads us to the science of risk communication. So risk communication is the science of helping people intuitively understand risk. And so in EPP and in engineering public policy department, and in some of my research, we use the mental models approach. So the mental models approach has 3 components: constructing an expert model, constructing a lay model, and then doing risk communication. So the expert model tries to summarize the science in some sort of model. And this can be multiple experts giving expert judgments. This can be a data analysis. This can be some combination. I'll give an example. This is a study that we did recently looking at predicting adverse pregnancy outcomes. Like in the top right, we've got low birth weight, we've got gestational weeks, which is related to preterm birth, preeclampsia, et cetera, and trying to relate those adverse pregnancy outcomes to other potential precursors and pathways that could be mitigated. This was based on an observational study of first-term pregnant women. And we used a graph learning model to represent the relationships between the vertices in the graph, where each of the vertices are random variables that were measured in the study. And if they're connected in the graph, then they are conditionally related, which means that even after controlling for every other variable in the study, these 2 variables that are connected in the graph are associated with each other. And so This is just one example of an expert model that was informed by both expert clinical judgment as well as a statistical data analysis, where we looked at these risk factors. Some of them include biomarkers in the bottom right, psychosocial risk factors in the top left, demographic risk factors in the bottom left, and important adverse pregnancy outcomes. And this is one way of representing the science. The next approach is to determine what the lay audience knows about that science. And so here we use semi-structured interviews. These are interviews that start by allowing people to describe the topic the topic of interest on their own terms, and then narrowing things down repeatedly such that we get to focus on the topics that are covered in the expert model. So what we want to do is understand the intuitive theories and leverage of lay people and stakeholders, and leverage that knowledge for communication. And it's very important because we don't want to put ideas into people's heads. We don't want them to try to guess at the answer that they think we're looking for. We want to know what they actually think. So for example, if you don't give people a chance to respond on their own, and you don't give the semi-structured interview approach here, you might not notice something like this. This is a result that came from testing a labeling approach on a particular drug that used a semi-structured interview approach. And what they found was that some people interpreted a red circle with a slash over a pregnant woman as meaning that the product was contraceptive, whereas other people thought that pregnant women should avoid it. And so these are two sort of exactly opposite conclusions that would be drawn from the same graphical representation. And the semi-structured interview helps that idea come out. So in the interview protocol, we start with an open-ended question on the topic, expand on the issues that are raised, and then we gradually make the interview more specific, focusing on the expert model to see whether people understand the science. And then we construct a lay version of the expert model, which is what an individual layperson believes. So an example of how an inaccurate mental model might lead to a potentially suboptimal decision and how risk communication could help is that, for example, most people know that radon is a colorless, odorless, and radioactive. But they do not understand that the radioactivity is not permanent, and so it has a short half-life. So if you don't understand that it has a short half-life, then you might not bother to test, and that's because regardless of the testing, you make the same decision. So if I don't find radon, then I'm fine, and if I do, I can't remove it anyway. So either way, my decision is not affected by the test, and so therefore I should not test. So this inaccurate mental model would lead someone to not test for radon when in fact they should. Then bridging that gap between the expert model and the lay model, that's the job of risk communication. So the risk communication approach can analyze the mental models and try to figure out what are the ways of making the lay model look more like the expert model by, for example, correcting mistakes, correcting beliefs, and adding missing concepts. A calibration analysis can help correct confidently held but incorrect beliefs, as well as reinforce correct but uncertain beliefs so people feel confident in their decision making. And the most important overarching theme is value of information analysis, using the expert model and the lay model to understand which components should really affect decision making, and then helping focus people and focusing risk communications on those key pieces of information that people don't already know and definitely need to know. And this comes from talking with them and trying to understand their mental models. So a big barrier to this is experts. So experts often feel like we should be able to just give people the numbers and they should understand that it's not a big deal and we don't need to go through all this rigmarole. So this has been well known for some time, and I'll just briefly talk about the process or the stages of development in a risk communication process. And basically, the risk communication field has worked in this process itself. So it has gone through all of these stages. And then every time a new risk communication project comes up, they also go through these stages in the project, and sometimes don't get all the way through. So generally, the field started, and in a new project, they start with, well, let's just get the numbers right. Let's just get the quantitative estimates correct, and then that's all we need. And then we need to just actually convey those numbers a little bit better and make sure people really understand them. And then we just have to explain what we mean by the numbers. And then we just have to show them that they've accepted similar risks. So you drive, so this is a lower risk. So you should accept this one. We need to show them that it's a good deal for them. So talk about the benefits, treat people nice. So be more like a PR person, and then make them partners, try to understand people's own individual perspectives and knowledge. And obviously that's where we're coming from in the risk communication perspective, that we're trying to understand not only what we want to communicate, but also what people want to know, what they need to know, and take any private knowledge that they might have into account when constructing risk communication. So I'll give some exemplars of excellent work that's, as far as I'm concerned, state of the art in risk communication. So I'll talk about the Canadian Standards Association Risk Management Guidelines, the FDA Benefit Risk Framework Drug Fact Box, and the elicitation and communication approach that Dr. Fischoff and I have worked on. So the Canadian Standards Risk Management approach is, again, an overarching approach that characterizes the best in practice in risk communication. It begins with some initiation, and here we have things like defining the problem, the stakeholders, the important outcomes, some preliminary analysis where we do a little bit of number crunching, and get feedback from the stakeholders, do risk estimation, evaluate the risks and benefits and see if they are acceptable, evaluate control and monitoring and mitigation efforts. But one of the most important and innovative elements of this framework is that risk communication is part of every stage of the risk analysis, that there is a two-way communication with these double-edged arrows here, where the risk analysts are talking to the relevant stakeholders and the stakeholders are talking back, such that both teams can make sure that their concerns are addressed throughout the entire process. So this two-way communication might increase the cost of analysis, but it can also increase the expected benefits if you want to think about it in a cost-benefit cost-benefit terms, because that benefit can prevent poisoned public discourse when it seems like the risk analysts don't really care. Another best in practice is the drug fact box. This is extensively tested on FDA-approved drugs to try to communicate risks and benefits. This was Lunesta as an example. It has a very simple description of what the drug is for, who might consider taking it, whether you need to monitor, other considerations that you should do when taking the drug, and how long it's been in use. And it does include quantitative information from these studies that were used to support the FDA's approval decision. And this, again, there's behavioral studies that show that people can go through and look at this and get the relevant numbers, and they can tell, well, does Lunesta help? Well, Lunesta leads to people falling asleep faster, so they fall asleep 15 minutes faster compared to placebo, etc. So people can go through this, they can look at the numbers, and they can get a sense of the benefits and potential risks. Here we have the symptoms at the bottom, potential risks from the drug Lunesta. The FDA implemented the benefit risk framework around 2013. And again, this is a very simple communication framework where the FDA's decisions, and this is a little bit more toward organizations and industry, but there's an analysis of condition, current treatment options, benefits, risk, and risk management. And then there's the science, which is the evidence and uncertainties. And then there's the conclusions and reasons. And this is more of a qualitative statement and about the reasons for action. And so again, an analysis of condition. Here there's a tumor, a gastrointestinal tumor condition. It's a serious disease that's frequently fatal. There's a description of the disease. There's a description that most people benefit. And then finally, there's this communication framework that Professor Fischoff and I have worked on. It involves identifying key outcomes, summarizing variability, summarizing internal validity with respect to causation, external validity with respect to generalization, strength of science, and uncertainty. So the strength of science is a novel part of the framework, looking at directness. So in general, how well do a field's measurements capture key outcomes? Is there a strong empirical basis, or are they just observational studies? Are the studies based on high methodological rigor? And how theoretically validated are the results? And at the end of this, we ask participants, experts in this case, to make a critical interval judgment where they are asked to say, taking all of the previous issues into consideration, I'm 95% certain that the true value of the critical outcome is between Y and Z. So all of these issues are described in the, or many of the issues are described in the FDA Communicating Risks and Benefits book mentioned here. And in general, the principles that I just want to hit home is that it's possible to do risk communication and uncertainty communication with respect for stakeholders so they don't have to struggle to be heard. Where there's relevance, that they know what they need to know, and that's self-defined, and it's not giving them information that they already know, and that testing is key, that it's critically important to collect empirical evidence on communication effectiveness, and then to iterate. Thank you very much for your time.